Hello students, today I'm going to teach you about the data generalization and summarization in data mining. The data generalization. Data generalization is a process which abstracts a large set of task relevant data in database from a low conceptual level to higher ones. In simple word, we all understand that there is a conceptual hierarchy in which the data with the more number of distinct values which are connected related to the data element with less number of distinct values uh, are placed in such order that number the data with the less distinct number value comes above the data values with more distinct value. So there is a hierarchy that's called the concept hierarchy. In data generalization, we find out the task relevant data means the data that are related to each other and related to a certain task. In that, we arrange the data in such a way so that the data, a kind of data with a least number of data elements comes at the root, and the data elements with higher values in are arranged in uh, in downward with increasing height. So in data generalization, we follow the concept of concept hierarchy, and the data are related to each other in related to each other in some uh, task relevant way. And there are basically two approach for data generalization. The one is data cube approach or OLAP approach, and the second one is attribute oriented induction approach. First of all, in data cube approach or OLAP approach, in OLAP approach, there are some efficient implementation of data generalization and computation of various kind of measure at count, sum, average, and max. In this data cube, we perform generalization, but there is a limitation that it can only implement a certain kind of formula, that is mathematical formula like average, sum, mean, max on the data. These kinds of operations are done with the help of two types of operation performed over data cube, like roll up operation and drill down operation. The roll up operation, in roll up operation, we move from the bottom to the top, and in drill down operation we move from the top to the bottom in conceptual hierarchy. This is used to handle the multidimensional data. In it, we can simply use mathematical formula, and it cannot do intelligent analysis. I mean, by an intelligent analysis, I mean that it cannot find out, compare two type of attributes which are different from each other. For example, I am giving you an example of the uh, person going to for a visit in a jungle safari. Suppose there are different kinds of animal there. During his visit, he saw two lions, three elephants, and four deer. It means in data cube we can mention that there were two lions, four elephants, four horse, yeah, elephant, etc. But we cannot tell that the total number of element, because it will consider all these different animals, all these as different species. It cannot you simply add all these attribute as a single wild animals, because it is or not already defined. So it is not intelligent enough to analyze that these animals belongs to the wild category and they are not pet animals. You have to in, uh, specifically design a schema so that these can be considered as the wild animals, and it cannot edit or modify a data. It means delete a attribute or change attribute, or it cannot go to analyze that hidden relation between the different attributes or entities. So it is not intelligent enough to analyze the attributes. So due to this limitations, it can handle only simple non-numeric data, and it can only perform the simple mathematical operation over it. In this limitation is very much easily handled by the second approach, that is the second approach that is sorry yeah, it's taking time, just a second. That is the attribute oriented induction. In oriented induction, there are basically some methods which are used frequently. In it, we perform generalization by attribute removal or attribute generalization. In attribute removal, we remove some attributes that are not relevant to our task. In that case, if some attribute can be removed, then it prune out that attribute. In this way, we simplify our data, and the size of data also get reduced. The another one approach is the merging the identical generalized tuples. In this, we merge similar kinds of attributes set together so that we can get a new dimension or new kind of analysis or a new kind of generalization over these attributes, which can give us most information and which are easy to handle. So these two methods, the removal of the attributes and merging of identical general tuples, are the sum of the common feature that are used in attribute oriented induction. Besides this, there are some other concept in which in it we find out the hidden relation, initial relation between the different dimensions or attributes. By finding out these hidden relation, we can generalize our data. These to find out these hidden relation, first we remove first what we do, we find out the generalization operator. It is the generalization operator is an operator by with help of which we can relate distinct values of the data set by a simple expression in terms of attributes. The attributes. The basic principle of attribute inductions are in this way are the attribute threshold control. In it, we can limit a particular attribute to a certain extent, and we can limit the threshold is decided by the need, our need, and the relevance to the task. So if some information is not relevant to our task, then we can simply prune it out, and 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 if it is above the threshold, it can be truncated, easily eliminated also. So yeah, and beside, so as I have already told you, if there is a large data set of distinct value of A and there exists a set of generalization operator on A, then select an operator and generalize A. But because by using an operator, you can generalize all these attributes by a simple expression of over the attributes. So finally, there are these are the techniques that are used on the attribute set induction. First one, elimination of some extra attributes, and second one is finding out an operational operator, generalization operator to generalize, and third one, to apply a threshold over a attribute set so that we can filter out only task relevant data. So now I'm going to give you uh, some more about the attribute oriented induction. First, the initial relation. Initial relation, as I've already told you, we find out the basic relation or hidden behind the different attributes through which we can generalize or relate these attributes with each other. That's called the initial relation between the attributes. Second one, the pre-generalization. The By generalizing some of the attributes through a given data set, we can generalize it to a higher extent by generalizing these prime attributes to higher once again. These are called the prime generalization. These are called the prime generalization. In it, we perform the generalization to the right level to perform the right generalization relation. In it, we generalize to a higher level, and it is applied over already generalized schema. So that's called the prime generalization. And another form of generalization is the presentation. In in it, we adjust the level by drilling. By drilling, we find out the new levels, or we reduce the sum of the level, and by pivoting. And another one is cross tab. I am going to give you an example of all these. That the First of all, the here you can see that there is a table in which there are columns with name, gender, major, birthplace, birth date, residence, phone, and GPA. Here we are analyzing that our task is to find out the educational interest of the different person in a certain area. Here, for this purpose, we are analyzing our data, and name is not very much relevant to our task because we are not interested in the name, and we are interested in the number of the candidates. So we simply ignore the name column, and the name column has been removed. It is marked here by a red red as removed. Again, for a, this is the elimination of example of elimination of attribute. And similarly, in column birth date, there are different date of birth. We are not interested in the actual date of birth of the client, and we are only interested in the age groups and their interest. So we find out the hidden relation, that there is a hidden relation in between date of birth and their age, and we generalize their ages with a certain range. Instead of birthplace, we find out a age range through which most of the item lies under the age range. There's 20 to 25 and 25 to 30. This is here we are finding out the initial relation between these attributes. And so this is an again example of generalization. Again, in the column residence, we are not interested in the detailed address, so we can simply limit it to their city only. So we have truncated the 4-5 length address to the single entity as a name of the city. So here a threshold has been applied over the residence column. Again, after that, we have again categorize GPA by a certain grading system, that very good and excellent. And so we are not particularly interested in their actual marks. So again, there is a generalization on GPA. And besides this, we are interested in finding out their graduations, where they are a student of science stream or art stream. So we have considered all the CS physics as the simply science student, and the other stream as art student. So simply there are two categories, and different categories have become generalized to as a different science streams has a generalized into a simple science, and art stream into art. So again, after doing all this, we have find out that this is the generalization. And as for summarization, we have again applied the count as the prime generalization example. We have calculated the number of count here of the number of this male candidate who are in certain age range and have got very good GPA, and this candidate female, similarly the female candidate who have got very good GPA and excellent GPA, like this. So this count column is again a prime generalization over the given generalized relation. So this is the example of prime generalization. And for the doing writing particular query, the DMQL is used for generalized query. For example, to find out the science graduate, the example that I have shown you earlier, we in SQL we write out our command like this: select name, gender, major, birthplace, birth date, residence from student, where student is in bracket MSc, BA, MBA, PhD. Here we are particularly mentioning the different stream like MSc, MBA, and PhD. But if we are doing the attribute level general induction, then instead of writing the particular stream, we are simply writing out the status is graduate and the characteristic as science student. Here, science students, all the stream of science will be considered into it, and the particular degree. For example, in engineering, a BTech student get MTech BTech degree, and in postgraduate he get a MTech degree. But we are not interested in their particular degree. We are simply defining a class and generalize that as the graduate. If somebody is MTech, then he would automatically be graduate. So here, science student and graduate are used as the attribute level induction, attribute oriented induction, and we are performing and the simple attribute oriented induction over the, and they are simple to write. Whenever we write the graduate, it will automatically take the reference to the graduate or science student, and it is very simple to write. That's all about the summarization and generalization data mining. Thank you. Thanks for joining.